Good afternoon, everyone, and welcome once again to the ECA Learning Zone webinar series. Today, our presentation is all about how monitoring can transform site power use and costs. Today, we're with ECA Commercial Associate Fuuse. Our guest and presenter today is Gary Hyton, Head of Energy Management Systems at Fuuse. Just quickly from me before we kick off today's presentation, you should see a question mark button on your screen now. Do please make use of this at any point in today's presentation, and we'll try to get to as many of your questions as we can at the end of the webinar. And finally, from me, today's webinar is being recorded, and the full replay will be available on our YouTube channel. That's at youtube.com/ECA Live. That's also where we host all of our ECA Learning Zone webinar replays. And if you are an ECA member, do make sure to visit the members area of the ECA website for guidance notes, technical bulletins, all sorts of guidance to help your business. And that's enough from me. I hope you enjoy today's presentation. Now over to you, Gary.
Thanks, Omar. Good afternoon. As you can see by the slide, just reiterate my name, Gary Hyton. Anybody that wants to contact me after the event, please feel free to make a note of the email address. And I'm the Head of Energy Management at Fuuse. Now, for the next 40 minutes or so, before we move into the Q&A session, we'll be covering why monitor energy use, what's the drivers behind it. Take a short look at where energy monitoring has come from and, more importantly, where it's going. Look at some of the technologies that are available now and how it will take us into the future world of the wonderful world of energy monitoring. We'll start to look at some of the insights. It's all very well collecting data, but how do you actually make it useful and actionable? So we'll take a few minutes to go through some sample insightful data views. What we're finding, Fuuse, I'll come back to Fuuse in a moment. Yes, we'll park that. But what we're finding is in a lot of our customer sites that use our technology, EV charging is starting to play quite a heavy impact on the site electrical infrastructure. So we'll take a look at that. And finally, some real life case studies of people using these insightful energy data to get the cost and the carbon down. So that's the agenda. Quick housekeeping point. Some of you may have looked on Fuuse for the subject matter today. Now, Fuuse recently acquired a business called Envisage, who provide a world-class energy monitoring package. So for the next month, anybody that wants to know more about technology, please use the envisage.com website. After that, you'll have everything you need on the Fuuse website. Now, Fuuse is an outfit, Fuuse.io, that provides, first off, EV charge point management systems, and through the acquisition, energy monitoring and management platform that brings the two essential services together. So moving on, why monitor energy use? Now, there are many reasons to monitor energy. I'll just cover some of the key ones that we see on a day-to-day basis. First and foremost, energy costs are increasing, and most businesses want to keep on top of this. So energy monitoring is used to help costs keep under control. The following from that, you bring your consumption down, carbon comes with it. We're all in a net zero world now, and it's increasingly helpful to get the carbon emissions down. On a more local level, peak demand management. As we move towards a net zero world, a carbon-free, a decarbonised world, more and more demand will come onto the grid, and the grid is putting carrot and stick places in place to keep peak demand down, peak demand off the grid down, and that's through increased tariffs or restricting supply. It helps make data-driven, fact-based decisions. A lot of people use it to check their bill accuracy. Is it actually right? The kilowatt hours that have been billed that month, actually did it happen? Lots of regulatory schemes out there now, such as ESOS and SECR. Monitoring helps with that. Performance, RI benchmarking. So if somebody's going to invest in some form of renewable or energy efficiency measure, such as variable drives or LED lighting or a myriad of other energy efficiency measures, then it's very important that some form of monitoring package can check the ROI projections. A lot of companies want their various stakeholders to know what's happening, especially if energy has been reduced. Load balancing is becoming a big issue as more and more sites decarbonize, put more electrical assets into their grid as opposed to gas. Load balancing is becoming a big issue. And laid on from that is site infrastructure has to be protected. You don't want to trip the site out, and monitoring will help you prevent that. For those of you out there that are value-added providers, such as contractors, consultants, or other people in the value-added supply chain, monitoring will help benefit in terms of income and profit generation and customer retention. And we at Fuuse, our ideal route to market is we provide technology through our value-added party. So electrical, we work a lot with electrical contractors and consultants and energy brokers. So the whole goal of taking data, and we'll see in the next few minutes a lot about energy data, but the idea is to turn that data into meaningful and actionable insights, and we'll cover that off in a fairly smooth manner. So in terms of data, there's various levels of monitoring and metering out there, and a lot of sites will have half-hourly meters fitted, so there's 48 data points a day available to assess some form of energy use, and that's a kilowatt hour level. That's useful for maybe looking at base load management, what's happening on site, out of hours, weekends, etc. But then you start to put monitoring into place, and then we can bring these data points right up to then give real big insights into what's happening at asset level, such as compressors or HVAC. What's wasted? What can I do to improve the efficiency? And then using these asset control systems, there might be for our handling units, for example, there may be controls in place to tweak and adjust timings or schedules, etc. And once you know what's happening and you can tighten up on existing asset controls, i.e. no or low cost adjustments, typically we find that about 12% of energy costs can be saved on these assets. Now, a lot of the time, there's so much data out there. A lot of people just want to manage by exception. So a lot of software in these energy management platforms, we're no exception, can provide alerts. So you can set up, I want to know when consumption goes above a certain level, when amps goes above a certain level. I want to be informed, and then you can take remedial action. So it's managing by proactiveness, really. And on a lot of site bills, those of typically over 100,000 kilowatt hours a year that are half-hourly metered, peak demand tariffs are evident on the bills, and those will increase substantially over the next 2 or 3 years. But at the moment, peak demand charges are about 15% of the bill spend. That's going up, so the more and more you can get on top of peak demand charges, the better. We find typically a lot of savings can be made via plugged-in devices that take up a lot of base load, and we'll spend a bit more time on that in a few minutes. And the more and more we can make people aware, constantly aware of how their energy is being used, they become more and more aware of it. I've just said that, and they'll take action to where they can to reduce. So there's some insights just on what's happening or what could happen on site by being a little more diligent. It doesn't take a lot to get energy use down. So moving on to the evolution of monitoring. Now, I've picked 2010 because that's when I started in the energy monitoring industry. And then it was mainly just meters at site level, gas meters, electricity meters, water meters, etc. And there are the meters set into the panel distribution board to provide what's happening now in terms of volts and currents, etc. But there's very little communications between these meters or the supply meters to really help people get to the bottom of what was happening. And this information was kept in silos, so anybody that collected electricity information couldn't or wouldn't be able to share with the gas information, for example. And very limited circuit level, so really people couldn't get to grips on what was happening within the buildings, and where they could, it was very expensive. The hardware and the software was really expensive, and in those days the software was really difficult to understand. And again, why invest? Because energy costs were relatively low, sort of 14 years or so ago. So let's fast forward now to today and out for the next 5 or 6 years. Considerably changed landscape. We've got a lot more renewables there. As I mentioned before, decarbonisation. The impact on the grid is going to be spectacular compared to as it has been for the last 70, 80 years. So what's driving this change? Nice pretty picture, but it really is underlying that is exactly what's happening in a more day-to-day basis. So what's driving this? The grid is really concerned as we move towards decarbonisation. A lot of tariffs are going up now to control peak demand, and these tariffs are going to change and increase as we move forward in the next certainly 1 to 2 years. On the flip side of that, the grid is going to enable wholesale market trading, where those sites that have got assets that can absorb or release or reduce energy at certain times, not so much the balancing mechanism, demand side response, but to actually trade their power back into or from the grid. Obviously, reduce carbon emissions. We know about energy costs. We're all painfully aware of those. Growth in EV charging, which is driving a lot of disruption into site infrastructure. More renewables. We've seen in the last 2 years more renewables come onto our energy dashboards than we have in the previous 8 years. So the cost of renewables is coming down. Decarbonisation is making people think more tightly about that. And the site infrastructure. You'll see these common themes come up time and time again, but this is really a reflection of what our customers are asking us to help them with. And those previously siloed pieces of information, in this instance, there may be information on inverters from the solar panels, or the battery provider, battery systems, or the EV charging management systems, or the BMS. All of these previously have been siloed pieces of information, data, but now increasingly people want to use that information in a central way. So these are all big drivers towards this changing world of energy monitoring. So fortunately, there's a lot of enablers out there to make it happen quite quickly. There are industry standards now in place, protocols that will allow this sharing of information between renewables, building, battery, EV charging, and the grid. Some of these new protocols have been around for a year or two and are now being put into place by software platform vendors. The underlying source of data, for the data acquisition hardware is coming down. The complexity or the sophistication is going up, and the communications options are getting richer, which leads in, typically we're now seeing that the two main ways of moving data back from site into a central database will be 4G and LoRa. LoRa increasingly as the network rolls out in the next few years. I just mentioned the cost of renewables is coming down, so it's easier to deploy, easy to reduce peak demand, easy to store power into batteries. This mention about getting rid of the silos so we can share information. Software APIs are now freely available from all these vendors of different management systems to allow people to get, move, provide data for people to action. The hardware on site is much easier to install than it was maybe a year or two ago. A lot of vendors, ones we use and suggest, for example, it's really simple now to install a lot of the hardware. You don't need to take sites down typically, or distribution boards that maybe needed to be taken down a while ago. And of course, artificial intelligence. Now this next slide, which is very busy, which I won't go through with you, most of you will be probably pleased to hear, is this is an example of some of the data sets that we're currently working on in terms of integration of data. I won't go through this at all, but needless to say, we understand where the direction of travel from our customers, and we're developing software to help us achieve all of those goals. And these are all the different protocols that we have to deploy depending on what we're trying to achieve. Now, smart metering, now into the today, really. We're now moved away from the world of the next 3 to 5 years and into today. And anybody that's putting energy monitoring system into play has to really deploy a selection of data acquisition hardware on site to gather that essential data. So we'll start from the most basic one, which is half-hourly meters on site that are provided by the suppliers, meter operators. These will give us typically kilowatt hours, low granularity, it's every 30 minutes, and typically the data is delivered next day via pre-built FTP communication system packages. It's useful information at site level, but when you need to dive deeper or bring in more energy sources, then you have to move to the next one. So we also deploy pulse loggers, so those are for connection to non-half-hourly or smart meters. And typically where you've got sites that want to monitor not just electricity, but gas, water, renewables, export meters, etc. So if there's a pulse available on a meter, these data lockers can grab that pulse. It's got limited energy data, which is kilowatt hour only, but the granularity can increase from the 30-minute on the half-hourly between 1 and 30 minutes, depending on the client's requirements. And this data is delivered via SMS, can be within a minute, 30 minutes, next day, as needed by the client. We then move down the chain into the building, so to circuit level monitors, and then the data becomes richer, more we can look at volts, amps, power factor, etc. on a per phase basis. It's very high granularity, down to 5 seconds if needed, and the data can be delivered via the client's network or Wi-Fi connection. And now we move up to the latest technology, which is the Internet of Things monitors. Again, these are driven by CT measurement, and it can be site or circuit level. The same level of data, but now the granularity increases up to 1 second. And these 1 second granularity devices are needed for grid balancing programs, such as the balancing mechanism, data load balancing on site. Very fast reaction times are needed, so hence the granularity of data movement. Can be delivered by 4G. The data has inbuilt APIs for sharing in real time. These devices can also have onboard switching fitted, so we can start to switch on-site assets on or off, up or down. And these the modern protocols for interaction with inverters, battery management systems, EV charging systems, these are embedded. So this becomes a on-site controller. And a selection of these can be deployed on-site depending on the client or the site requirements. These are in use today. It's not future, this is actually today. And the other part of the jigsaw is there's a huge amount of data now required or produced by a site, energy data, and this needs to be stored. It needs to be stored at a relatively inexpensive cost. It needs to be restored with very quick retrieval and with a very high uptime. And the two beasts in the marketplace are, you can see here in my view anyway, is AWS and Azure. And without the cloud data services, the world of modern energy monitoring really wouldn't prevail. There's one snapshot of our portfolio as an example of a reasonable or good or great, depending on your point of view, energy monitoring and management system. It can start with power audits, an automated report that looks at before and after introduction of fairly high impact electrical assets such as new data centers, EV charging, etc. on site. It'll help look at the impact on the electrical infrastructure. A world-class energy monitoring package, which can then lead into demand management to switch devices on or off that are identified by the energy management team. And we'll have a look at some case studies about that in a minute. If load balancing is required, again via APIs, then working with other vendors, key vendors, load balancing can be achieved. And then down the line, in introduction of V2G and V2B applications, of which there's an example here. So this is a load balancing example, and at the same time, it's providing energy monitoring services into the site for other applications than just dynamic load balancing of EVs. So in this instance, we would set in the breaker rating into our database as this is installed. The monitor will provide into the database real-time or virtually real-time data every 5 seconds of amps per phase. At the setup of this, when the charge points are installed, the client is requested when would they want dynamic load balancing to activate, and we'll say 90% when it reaches 90% of the site breaker rating. So what will happen here? These are using two protocols: energy monitoring protocol here and the EV charging OCPP protocol here. If any phase reaches 540 amps in this instance, then EV charging will be turned down and kept down until the demand off the site decreases and then charging is increased. This is just a typical example of some smart energy monitoring technology in play today. And here's a visual representation of that. EV charging is active. This is off a distribution board providing EV charging services. The site on the demand on the site is low. EV charging goes up, exceeding that threshold that we've just had a look at. You can see by the little control on the day-to-day basis of the demand. Then this is dynamic load balancing in play. You can see it's not great big steps. It's very finely tuned. It's just keeping below that building level of how many amps. The demand comes off the building for whatever reason, 12 o'clock, maybe lunchtime, things are switched off. So the demand on the building is less. We have more power to EV charging, and lo and behold, the EV charging session fits. This is an example of high intensity 1-second energy monitoring. This is off our engineering dashboard that's not readily available because the data off this is quite expensive, but it can be made available to our customers if needed. Here's another way we've got some technology being evolved. This is mainly used by providers of battery and PV management systems like Tesla into the home. It's not, these power flow applications aren't readily available for the commercial and industrial world yet. We'll be rolling out in about 4 or 5 months the ability to have real-time power flow across 7 or 8 different electrical assets. That might be a combination of battery, PV, different parts of the site. This is going to be really key to help make decisions when it comes to grid power, wholesale power management onto or off the grid, and do I invest or not need to invest in battery, etc. And this finally on the smart technology section, this is an example of the Internet of Things, our circuit monitors in play. This particular dashboard view is there's an air handling unit that's on 24/7. The client recognized that it actually didn't need to be on 24/7, only at working hours. So the version of this Internet Things now switches a contactor on or off to a schedule, and you can see the after effect of that. We'll look at that in a bit more detail. Now, you've got an overview now of the technology, but the technology is only as good as its use or the people that use it. So there's 6 suggestions here on how to get the most out of any investment in its technology. 1, use it as often as can be acceptable, and use it to understand what's happening on site. Become familiar with what's happening on site. And the deeper you monitor, the better your returns. And I'm not for one moment saying monitor 13 amp ring mains. It's the depth of useful monitoring. So we always go along when we talk to clients, is start with the 80-20. Typically 80% of your energy on site will be used by 20% of the electrical assets. So what are those? And that's a good starting point. Engage often, and typically, use expertise. So if you're looking at some HVAC systems, have somebody around that understands what HVAC's meant to do and when it's meant to do it, and they can interpret the data and produce insights out of that. Empower the stakeholders to use it, to come up with suggestions. There's no such thing as a silly idea when it comes to energy efficiency. And a lot of energy management systems are feature rich, ours included, and maximize the use of them. There's a lot of stuff it can do. It's not just about looking at kilowatt hours cost and carbon. There's a lot more information available. And once you've got these ideas, use best practices, and we'll look at best practices in a little more detail in a moment. So it's not just about technology, it's how it's used as well. Right, let's have a look at some insights out of an energy monitoring platform. In this instance, it's ours. So one insight here, this is just looking at kilowatt hours, looking at it over a 60-minute basis, just kilowatt hours per minute, and there's 3 months that you can change these timescales to reflect how much data you've got in a can. Now, the immediate observation I would take from this is that the base load is quite high. You can see 24/7, it's 50 kilowatt hours, regardless of the time of day, at night, weekend, etc. And that's a lot for a site that's peaking at around 125. So one of the areas to look at, to maybe dive a bit deeper into, what's causing this base load? What's causing it? What can be controlled? What can bring it down? Another one is, this is a demand screen. Looks very similar, but it's a different part of the software or the platform. In this instance, it's looking at KVA. The red dotted line is the contracted KVA from the grid, and this is the KVA use on site. So out of 97 KVA is the contracted capacity from the DNO. Peaked out at 67, and there's 30 left. Now this is, you can see here, this happens all the time. So that 30 maybe should be reduced by about 20 kVA, and that could save the client about £600 to £700 a year. Now this is a fairly small site with this level of demand, but it's so, saving £600 to £700 a year is a pretty good ask for one letter back to the DNO, back to the energy supplier. Here we can also, on the platform, we can look at volts, and in this instance you can see here this voltage is peaking on this particular phase at around 252. Now that's obviously really high when 220 is optimal. So what can be done to bring that voltage down? We'll have a look at that in a few minutes. So this is an insight. It's really clear. This is causing a problem because it's unnecessary voltage levels, what could potentially save energy and take some of the strain off your electrical assets. Another insight would be, in this instance, we're looking at things in kilowatt hours, and this site's exporting power. from obviously PV. Now, what can be done to soak that up? Because it's no good really exporting anything. You don't get paid, or if you do, it's very tiny unless you've got the FIT from years ago. So what can be done to soak that power up? At least you know now, or the client knows what's happening and when they can be alerted if need be. But if you take proactive action, what can soak that up? Can turn on water heating? Can you charge EVs that are plugged in but not yet charging? Can you turn on compressors? Can you turn up your freezers? What can be done to soak that power up? And what we are doing, and most other vendors will be doing that, is they'll be automating this. So if power dips below 0 kilowatt hours or 0 kilowatts, goes into the negative, then we can take automated actions on what to turn on or off when it goes goes back above the zero line. And I'm going to provide 1 or 2 slides on the impact of EV charging. And I know I've covered that in some detail, but it really is impacting significantly on customer electrical infrastructure. This particular customer, we're looking at things on amps on 1 phase, L2 at the moment. The customer was starting getting alerts in July last year that the demand on 1 or 2 of his phases was peaking above the breaker limit of 250 amps. And you can see these are spike driven. These are the day-to-day ebb and flow of this particular site. These are spikes that have just suddenly appeared. And working with the electrical contractor, we talked to the client and what could possibly cause these spikes. So after a bit of investigation, we monitored the EV charging, 50 kilowatt EV charger that had just been fitted without, in this particular instance, without much consultation on the possible impact that this will have. And you can see what's causing these spikes. Here you can see on this particular one, that's gone up when the site is peaked at around 12 o'clock, then EV charging goes on and that drives it above the breaker limit. Now, since the customer's implemented dynamic load management, and that chops the tops of the charging before it gets to within the breaker limit. Okay, the final one now, some case studies. Now, case studies resolve themselves out of best practices. So here's a couple of best practices, pretty straightforward for anybody that uses energy monitoring. We've got to get the right data from the site in the right format, hence the hardware needed, select the right hardware, and identifying the areas I talked about the 80-20 before, so that's a good starting point. And then once you've got the data, start to look at insights. What can be done to actually improve things? What can we turn things on and off automatically, up or down? Can they be turned off manually? Do we need to put some retrofit in place? And then once those decisions have been taken, monitor the data to see if the ROI is working. So typical standard best practices. Let's have a look at it in action. So we'll go back to this slide we showed before demand management, after demand management, and using the verification part of the platform over 1 week. So what we're looking at here is the blue line is the after, the second period, or the after effects, and the first period is before. And the little grey shades are the savings. So here we can see the difference in a week. This is on 1 air handling unit, incidentally, just 1 air handling unit. So it's saving 26 quid in a week and 20 kilos of carbon. If we fast forward this now 3 months, we can now see the savings have ramped up to 315 quid and 1/4 ton of carbon. Now, the annual savings of this will be about £1,000 and the ROI is 7 months. And the clients rolled this out to the other 6 air handling units on site that aren't required during non-working hours. So pretty straightforward. Spotted that it was on 24/7 and took some easily easy to fix measures to put some form of switching into place. In this instance, it was our Internet of Things monitor driving a contactor that takes out the handling unit during non-working hours. Here's another one on no low-cost energy savings, voltage. So here we are at on three-phase voltage now. This instance, it was spotted to be too high. The DNO, when contacted, said yes, they could tap down the local transformer, which they did. And here are some of the savings. So we tapped down by 7%. That led to about 4% in savings in consumption, which equates to nearly 10 tons of carbon a year and an annual saving of 10,000 quid for about a £3,500 DNO exercise. So that's a pretty good no low cost savings. Plus, of course, the voltage has come down, so there's less stress on the electrical assets. And finally, here's one using one of our older energy monitoring dashboards. LED lighting, it was spotted that metal halide lights were being used in a warehouse. Pretty basic really, get the LEDs in. But this was a reflection of planning for it. So this was the actual project underway. On this slide here, you can see that this was the daily before during the working hours, and this was a result of the LED retrofit in terms of verification, and it worked out. The ROI actually worked out better. It was set at 3 years, but it came down at 2.4. And that's it. That's my view of how to get good energy insights out of a good energy monitoring platform. Just to reiterate, if you do need more information, go to envisage.com for the time being. Within a month, you'll be able to go to fuuse.io. And here's my email address if you need to get any more information out of me. That's it, Q&A.
Brilliant, thank you, Gary, for that fantastic presentation. Before we jump into the Q&A, could you please repeat your contact details for anyone that wants to get in touch?
Sure.
They're on your first slide. There we go.
Yeah. I'll leave that.
Gary, so, yeah, that's great. So we've got 3 questions here. First one, you mentioned depth of monitoring. The new building regulations Part L requirements define each lighting circuit to be separately metered. What are your thoughts on the value of metering each circuit individually rather than end use category and the most appropriate approach?
Up to now, we've never been required to, by customers or any other stakeholder, to monitor each individual lighting circuit. It's typically at distribution board level, if it's a dedicated distribution board, where you get great insights just at dB level. You can see certain things go in and out at different times maybe, but overall you get some great views. But we've never been asked to participate in that level of monitoring yet on lighting. We get great insights just a bit further up the scale.
Okay. Next question here. Where can we get a list of your case studies by which we can convince our clients to use power management? Can you send these to us?
Great question. I'm happy to provide a copy of this presentation.
Great.
Omar, perhaps you could advise on how you can distribute it.
Yes, what I can do is, yes, Gary, if you send me a copy of the slides, I can get that to our attendees if they wish to receive a copy. That's fine.
Sure.
Great. Couple more here. Can you share with us the scheme to understand what all the equipments are to be procured and their costs?
Sure. If I think the best way to do that, we have a standard equipment lists, etc. Generally, we work with our customers, be it the contractors or whoever, to work out what needs to happen on site, and then we'll provide specific quotes. However, I'm more than happy to provide to share the equipment list and work with people to look at which is the best one to use in different circumstances. Typically 1 or 2 engagements on a project, and our clients are away and flying. So if the person that asked the question wants to contact me directly, I'm more than happy to share that information with them.
Great, thank you, Gary. And we had someone ask about the website showing an error, but that seems to be resolved. The website seems to be working. Envisage.com, that seems to be working all fine. So that's all good.
That's good news.
Okay, yeah. So that's all from us today. Thank you very much, everyone, for joining us in the ECA Learning Zone. Once again, this session is recorded, and all of our replays are on youtube.com/ECA Live. Make sure to make full use of your ECA members area as well, if you're an ECA member, with lots of updates there, weekly guidance notes, technical bulletins, etc. And big thanks to Gary for your fantastic presentation, really excellent stuff, and to Fuuse today. And that's it from us. Hope you enjoy the rest of your day.
Thank you very much. Thank you, everybody.
Thanks. Thank you.